Welcome back. We'll be looking at some exercises about polymorphism, abstract classes, and virtual functions in this video. So without further ado, in our first exercise, we're going to be demonstrating what it is to be an abstract class with some pure virtual functions in C++. Our class is going to be called GameEntity. It's going to represent things that might be in a game. And it's going to have some pure virtual functions render, update, and load, as well as an implemented constructor and display function. So let's give this a start. So in here, we'll make 06B. This will be polymorphism. And let's start by making a file that I believe will be our GameEntity.h. Probably going to want IO stream, I imagine. Our class is called GameEntity. And we'll put all the properties in here, and then we'll write the code in GameEntity.cpp. I also am going to want to grab the make file from our last exercise, and I'll modify it as necessary. So let's go grab my make file that I like to pass around. And my make file, I guess for now we'll leave it as this, and we're going to make game. Okay. In my GameEntity class, we'll have some public functions, which will include a virtual function void render equals 0. And so here what I'm doing is I'm saying that this function is not implemented by the GameEntity class. It can only be implemented by the subclasses of GameEntity, which means I can't build a GameEntity. The same thing will go for our other functions, which will say our update and load. But we will implement a constructor. And so probably our GameEntity wants to have some properties. I imagine we'll want to have a string that's the name of our GameEntity. And let's also have a string that represents the, I guess we'll call it appearance. This will be the thing that actually shows up. And perhaps we'll have a character symbol, and the symbol will represent the GameEntity. Okay, now my GameEntity is going to need a display function, and this one I'll actually need to implement. And we're also going to need to have a GameEntity constructor, which is going to need to take a string name, a string appearance, and a character symbol, and apply those to the name appearance, which I suppose will be name n, appearance a, symbol s. Looks good to me. Okay, so I have my GameEntity class. I should be able to compile this. G++. Well, actually, no. First, I need to make a GameEntity CPP file that's going to implement my display function. So let's actually do that before we go any further. So GameEntity.cpp is just going to have my class, and I'm going to need to implement display of the GameEntity class. And we'll include GameEntity.h. And here I will simply output, and let's see, how do I want to display the GameEntity? I think I'll just say, just list the attributes of it. So name, and then the appearance, and the symbol. And we'll give it another end line just for kicks. Okay, so I should be able to make this, and this will be GameEntity.cpp. And here I just want to make the -o file. I suppose what I'll do is I'll make a main. Yeah, let's just make the main now. Why not? Main. My main here being main. Let's include GameEntity.h, which means that because I'm including this a couple times, I'll need to make sure this has pragma once. And here we'll make a game entity GE, and we'll give it, you know, let's say Pac-Man. Its appearance will be, let's say, greater than and a O. And let's say that we add a symbol of an O. Oop. Now we'll use these symbols later down the line, but right now I just want to make sure I can make this game entity and, importantly, display it. Sorry, I say should, but I'm actually not going to be able to. We'll see why in a second, which is, if I run make, oh, I need to include all the files I need. So my make file should have game entity and main. And we'll see what the one error I get is, which is that you cannot declare a variable GE to be of an abstract type game entity. And this is because game entity is an abstract class. It has virtual functions, render, update, and load, which means you cannot make a game entity. So this stuff I put in the main function, actually not valid. You cannot do this. So not valid. But I should be able to make it if I comment that stuff out. And everything compiles and runs okay. So I have my game entity class. It has what I need, and now I can move on to the next exercise where I can actually try to make objects that are game entities. So with that in mind, let's make two classes, character and item. They will be derived from the game entity class, and I will implement the virtual functions with functionality specific to these characters and items. So let's put all this into exercise 1. Let's make clean first. Okay, so these will go into exercise 1. I'll make copies of them for exercise 2. Okay. So now I need to have a character.h, which will include GameEntity.h, because a character will inherit publicly from the GameEntity class. Yeah, that looks good to me. I'm going to want to be able to make a character. So with the character constructor, I'm going to need to have their name, their appearance, the symbol that represents them, and I suppose that's probably fine. And I will simply pass this all over to the game entities constructor, NAS. Now, in order to be able to instantiate characters, I need to implement the functions that are virtual for game entity. So for now, I'll leave the display function. I think that one is fine. I don't need to really do much about it. And that's why I wanted to leave this public, because I don't want display to be private. But I do need to implement render, update, and load. So let us make a duplicate of this, which will be character.cpp, which will include character.h, which therefore should probably have pragma once, because I know I'm going to include this multiple times. And here I need to implement these three functions: void, character, what are the names of my functions here? Render, update, and load. Render, update, and load. I guess we'll do these in reverse order. So when I load, I will simply say loaded character, the name of the character. When I update, we'll take the appearance and add the symbol to basically change the way that it shows up. So we'll say old appearance of name colon appearance, and then the new appearance. And then finally for render, I will simply output the appearance. Just some simple ways that the rendering might be handled. Now, I have implemented these functions. My character inherits from GameEntity, which has already implemented display, for example. Now let's go into our main. We're going to include character, which by extension includes GameEntity. Let's make a character, C, which I guess will be our Pac-Man. How about we just do the greater than for now, and the O. And we'll do c.load. Basically call each one in order. Actually, let's do display first. Then we'll do display again at the end. Load, update, render, display. And just see what all these things will do. Back to my launcher, I'll run make run. Okay, what did I mess up? It looks like the following virtual functions are pure within character. GameEntity render, GameEntity update, GameEntity load. So it looks like I have mislabeled them. Oh, I know why. It's in my make file, I have not compiled character.cpp. That will help. Okay, let's try that again. Oops, still unhappy about it. Okay, interesting. Include character.h. I think I may have to indicate that these override the original game entity. Oh, actually, did I put them in here? No, I didn't. So that's my problem. So in here, I need to mention that character has implemented render, display, or not display, load and update. Okay, let's try that now. Clear. Make run again. Okay, now what's the problem? The appearance, the name, and the symbol are all private, and that's because I made the mistake of, in my game entity, making these private. When they should not be private, they should be protected, because I want my subclasses to be able to access the name, appearance, and symbol. Okay, trying again. Clear. Make run. Hey, look at that. I'm a Pac-Man. He starts out as a little mouth with a O symbol. I can load him. I can change him to add an O, and now oh, and when I display it, looks like I don't display a new line. So let's fix that. In my, let's see here. So in character.cpp, I need to add a n line. And now when I make, I only have to rebuild the character because the game entity didn't change, and now it looks like everything prints out exactly as I like. Hooray. We'll follow the exact same process for making an item. So let's first do make clean to clean this thing up. And now let's duplicate character and the character files because I want to just make this item.h and item.cpp. They're not going to be that different. My item.h is obviously going to be called item. It's going to need to have an item. It's going to have all the same stuff. My item.cpp is going to need to have item, item, item. Down here, and we'll say loaded item. Basically the same. Like for now, I want to treat them identical. Perhaps you could consider making it so that the maybe when the item's updated it doesn't change. We'll just say updated item. Sure. Now in my make file, I need to add item.cpp. It's a new file that's there. In my main, I need to include item. And now let's make an item. Item IT. We'll call it power pellet. That looks like a dot. Just write literally dot. And we won't put any symbol here for it. And then we'll just do all of these methods for IT. with a space in between. All right, let's see what happens. So clear it all up, make run. Oh, what did I mess up? I guess it doesn't like me putting in an empty character. It has to have something, I suppose. So how about we just give it a space? All right, now we got our Pac-Man, and we can load up Pac-Man, render him, and display him. We got our power pellet, which looks like a dot. There's no symbol. It can load it. Updated does not do anything because I asked it not to. Prints out the dot. And now we have our little system here that's going, where I have a combination of characters and items, which are all game entities. So if I decide that I want to, for instance, change the way that the display works, I only have to change it here. I don't have to change the item display and the character display. They all share the same method, so I can just modify it here. And there we have it. Okay, let's move on to the next one. All right, next step. Make a game loop that has a vector of game entity pointers, and in each iteration calls the update and render methods on each entity, demonstrating polymorphism. So this actually is not too difficult. It won't take us much time at all. First, let's clean everything up. And I'm going to take all of this and begin exercise 3. Okay, and here I'm mostly just going to be working on the main. We'll get rid of all this stuff. I do still want to have my Pac-Man and my power pellet, but here I'm going to include a vector because I need that, and we'll make a vector of game entity pointers, which we'll call entities. And I can say entities.pushback. Oops, I need to do it after. We'll make our things here. And how about I'll make a second power pellet just for fun. So this will be power pellet 2 ... And now I can call it T2. Let's push back the address of my character, the address of my first item, the address of my second item, and now for game entity pointer GE in entities, I can say GE arrow load. Or how about we load them all first, because that's kind of what would be normal to happen. So c.load it.load it2.load. And then in my loop, I will say GE arrow update render. And for the purposes of display, how about we remove these? Okay, I think I'm happy with that. So now I'm going to, I guess I want to put this in a loop. So how about we have a loop that just goes, say, 20 times. Actually, let's make it a proper while loop. So string input is new line, or empty string, while the input is not equal to x for exit. We'll do the thing, enter x to exit or enter to continue, and we'll read into input. And now we can constantly render our entities. Okay. Didn't make any mistakes. Let's find out. Make run. Oops, what did I mess up? Oh no, I'm in the wrong, ooh, I hope I didn't mess things up too badly here. I think I modified all the wrong files, unfortunately. Yeah, I modified everything in the folders, but that's okay. If I'm not mistaken, what this means is that this still has the old code from before. Oh no, this is the new one. Oh wait, now. So maybe that just means I'm in the wrong folder? Make run. Yeah, okay, there we go. Oh, I guess I have to actually enter something. Can I do a getLine actually instead? Maybe getLine will allow me to enter nothing. Let's try that. There we go. So then you can see here Pac-Man's getting extra O's every time, and I can hit X when I'm finally done. I want to stop. But this sort of represents the way that actually a real game might work, which is you have some loop that goes on till it's time to leave, and every time the loop goes, for each entity you have, you update however necessary and then render it. And so we've kind of made our own little simulation here, which obviously could have more detail in it, but at least has the basic functionality we're looking for using polymorphism. You'll note that when I do the update, it updates the items, and then for updating the character, Pac-Man, it's just adding extra O's. So I'm modifying the thing that's being rendered. You can see over time the number of O's is growing and growing, because that's exactly what happens with updating a character, as we see over here, updating the character. Oh, hold up, is this the right? I thought I commented these out. Oh yeah, okay, that's what this is showing, is I commented out the wrong character one. Let's comment out this and this, because that's what I had wanted, and we'll return the comments to character.cpp over here. Very easy to mix up the files you're working on. So let's clear, make run. Yeah, and now you can see Pac-Man's just growing over time. Okay, a little cleaner looking. Anyway, aside from the point, we have represented polymorphism in that for each game entity, it does a different kind of update depending on whether it's a character or an item. And similarly, if my render looked a little different for items versus characters, then I could render them in different ways as well, depending on how things work. This only works, by the way, because my game entity class over here has said that these are virtual functions. Now they're pure virtual, so like game entity is abstract, but they have to be virtual when they're originally declared in order for them to be operated on differently when we're actually running our code. So you could actually implement them as virtual inside of game entity, but then this would potentially not be an abstract class, which is kind of what we want. We don't want someone to just make a game entity. It needs to be a character or an item. Otherwise, it doesn't make a lot of sense in our current context. Okay, let's clean all this up and then move on to our final exercise. Okay, last one. We're going to allow the user to generate new characters or items during runtime and add them to the game entity vector. Okay, so again, let's grab all this stuff. We'll close everything this time. Copy to example 4. Okay, so in here I have right now just the option to exit. So how about we say X to exit, C for a new character, or I for a new item, or enter to continue. And so then if input is C, else if input is I, then let's build a new object. Now, we should make a function to help us out with this, because right now I'm writing a lot of code in this main function, which I don't really want to have be too long. So how about we make a function, and perhaps I'll put it in my game entity CPP. We'll call this game entity. Actually, do I need to put it here? No. How about we make a new class for it? Discard my changes. We'll call this game entity factory, and this is sort of our first preview of design patterns, which is the idea of a factory. Here I'm going to want to include character.h as well as item.h. I want to make a little function here rather than a whole class. I could make a whole class for this, but probably just going to make it simple because I just want one function, which is going to be game entity pointer, because that's what it's returning, create entity, given a let's actually make it a character entity type. And so if entity type is C, then I want a character. Otherwise, I want an item. Now, how do I return a proper game entity? Well, I will say return a new character, and I suppose here I need to get the information. So how about I request all the information here? So we'll say cout, enter the entity name, and we need string name. We need string, what was it, appearance, character, symbol. And we'll read in the name. Let's do a get line. Let's actually read in the symbol as a string too, just for consistency, and then we can always change it later if we need to. So get line into the name. Then I need the appearance and the symbol. Appearance, symbol. And here we're to a new character, which is going to be name, appearance, cast the symbol to a character. I hope that works. This is one I may have to experiment with. I'm not totally sure. Alternatively, we'll return a new item. I need this game entity factory in my make file. And here I want to... actually, I don't think I'm going to put it in my make file because I'm actually just going to include it directly in my main. And now, since my game entity factory takes the letter C, for example, I can, actually there's probably a better way to do this. No, I guess it's fine. We will call create entity. We will pass it the letter C. So this is going to give us a game entity pointer, and we'll put that into our game entity vector. And similarly here, push back with I. Okay, well, let's see how this goes. I think there's going to be some bugs, but we can obviously fix them. And so let's see what happens. Okay, make run. What do we got? An invalid yeah, I thought this might be a problem, which is trying to be able to convert my string that I'm reading in to a character. Probably there is some shortcut I can use. I guess one option is for character and item, I can give them another constructor. Let's see, is there a shortcut? C++ convert string to character? Is there a function for this? I can make it to a character array, but I don't want that. Yeah, can I do a single one? Oh, I can just index. Yeah, that's smart. Duh. Okay. So we'll go with symbol 0. Symbol 0. Okay. And it says GE was not declared in the scope. Oh, because entities dot pushback. All right, let's try it again. Clear, make run. Okay, so right now we just have our Pac-Man that grows over time. Let's make a new character. My new character will be Mrs. Pac-Man. Very creative. She'll be looking the other direction. and we'll just have more lesser than signs. Or how about we do this? Sure. Oh, actually, no, it doesn't work because it's only going to take a single dash. Oh, that's okay. And so let's see what happens now. Oh, so now they're both extending like that. How about I make a new item? My new item will be wall, I guess. My wall looks like a line. We'll just give it a blank symbol. So now I got my wall item. I can make another character. Let's make a ghost. My ghost will have a surprise face, and the symbol will be an exclamation mark. Oh, look at that. And here, there we go. I built a little iterative program that allows me to dynamically create new game entities and put them in. You'll notice that the way that they are updated depends on whether it's a character or an item. So when I added in the wall, you'll notice that the wall doesn't ever change because it's an item, whereas my characters are, having little, sloppy animations, but animations nonetheless. And the only reason this works is because of the polymorphism principle, which is that in my main function, everything here is just a game entity. It is a pointer to my entity's vector. Points to different game entities, and they can be different kinds. They can be characters, they can be items, doesn't really matter. It can handle all of those. Now, note that this only works specifically because I'm using pointers. If you don't use pointers, you can't really get this functioning at all, actually. And in my game entity factory, which normally this would be a class, but I've decided to just kind of keep it simple and leave it as a single function. But you may consider making this a class instead. Has this create entity function that returns a pointer to a game entity. But notably, each thing that it returns can only be a character or an item because you cannot just create a game entity. It has to be a character or an item. Game entities are abstract. You can't just make one. So this function will dynamically create characters and items and then return the pointers to those things, which then get put into my entities vector and get updated and rendered over and over and over again until I'm finally done. Okay, thanks for watching. Hopefully this video was helpful for you, and I look forward to seeing you in the next one. Bye-bye.